Part 1. The slit that split you starts with light, but not the kind you bask in, not the kind that warms skin or floods windows. This light is smaller, stranger. It's a photon, a single particle, a single wave, a single contradiction. You've heard of the double-slit experiment. Or maybe you haven't. Doesn't matter, because it knows you. It's watching you, and you're about to watch it. Watch yourself fall apart. Imagine a screen, two slits, a photon gun, firing one photon at a time. One little piece of light passing through one little slit. But no dot, it doesn't go through one. It doesn't go through both. It doesn't go through either. It interferes with itself, like it was a wave. Like it was every possible path, all at once, until it hits the back wall and becomes one thing. But then you look at it. You place a detector to watch, to see, and the pattern disappears. The photon chooses a slit. The wave collapses. You ruined it by observing. The act of seeing rewrites what is seen. Do you understand what that means? Not just about photons, about everything. Reality is not real until it is measured. And when you stop looking, it becomes unreal again. So what? About your life, your choices, your memories, did they happen? Or are they just collapsed possibilities? If no one observes you, do you even exist? Part 2. Schrodinger's casket. There's a box. Inside is a cat. Also, a vial of poison. A Geiger counter. A single atom, unstable, balanced on the edge of maybe, if the atom decays. The counter trips, the vial breaks, and the cat dies. If it doesn't, the cat lives. Quantum rules say that until the box is opened, the atom is in a superposition, both decayed and not, the poison both spilled and contained, the cat both breathing and dead. And so the question is not what happens inside the box. The question is, what happens to you when you open it? Are you the observer collapsing the wave function, or are you the subject of collapse? This is Schrodinger's cat, but it is also your life. You live in a constant loop of unopened boxes. Every decision you might have made, every path you might have taken, every version of you that might have existed, all of them are dead cats in sealed containers, or maybe alive. You'll never know, because you can't go back and open them. And if you did, would you still be you? Part 3. The particle that knew two particles are born together. Twins entangled. They travel apart, vast distances, light years maybe. One ends up on your desk, the other a galaxy away. But they're still connected. You flip one, the other flips. Instantly, no signal, no communication. Faster than light, which, according to everything else we know, is impossible. This is quantum entanglement. Einstein called it spooky action at a distance. But even he couldn't explain it, because when you measure one, the other reacts. Even when they are too far apart for information to travel. It's as if the universe doesn't care about distance, as if space isn't real, as if time, cause and effect doesn't apply. So what about your thoughts? What about your pain? What if you are entangled with someone, something you'll never meet? What if every emotion is just a flipped particle light years away? And if someone else feels it, does it even belong to you anymore? Part 4. The observer effect. You look in the mirror. The light hits your face, bounces back, tells you where you are, but you've just altered yourself. To measure something is to change it. You can never know the exact position and momentum of a particle, because the moment you try to observe it, your observation becomes a disturbance. This is Heisenberg's uncertainty principle. But it's more than physics. It's why you act differently when watched. It's why consciousness is a prison of reflection. It's why your most authentic self dies the moment you try to understand it. Because self-awareness isn't knowing. It's distorting. To see yourself is to kill what you were before you looked. You can't escape it. You are your own observer, and your act of perception writes your reality. But what if you could look away? What if you never noticed? Would you finally become what you really are, or vanish into uncertainty? Part 5. The past that's not there. Let's go backwards. Not just memory. Physics. In quantum mechanics, many of the laws are time-symmetric. The equations don't care if time moves forward or backward. There's nothing in the math that says, the arrow must point one way, so why does it? Entropy, maybe, the second law, possibly. But in the quantum world, the future can affect the past. This is retrocausality. A measurement made now can determine what happened then. As if the outcome sends a ripple backwards, like discovering a message in a bottle and realizing you wrote it tomorrow. Your current choices shaping your childhood. Your grief warping your origin. Your observation sculpting the sculpture of what already happened. It isn't just illogical. It's terrifying, because if the past is mutable, then your memories are fiction. Your guilt is invented, and your origin story is a hallucination. If you can change what was, how can you ever trust who you are? Part 6. The collapse that never happens. You want an answer, so you measure. A particle exists as a probability wave spread across space, a smeared blur of potential. But when you look, the wave collapses. It becomes a single value, a definite location, a fixed state. Why? No one knows. There's no mechanism, no law, no force, just the collapse. But here's the question no one wants to ask. What if the collapse never happens? This is the many worlds interpretation. Hugh Everett, 1957. He looked at the math and saw something different. When the wave function collapses, it doesn't. Instead, you split. The universe splits. You observe the particle here in this world, but in another version of you, it landed there. And in another, it missed entirely. Every quantum event spawns a new timeline. Every possibility realized. Every outcome true. Somewhere, so when you made that decision, when you chose this job, walked past that door, said yes instead of no, in infinite other versions of reality, you did the opposite. All of those yous, living, dying, screaming, laughing, right now, stacked atop one another, echoes of unrealized choices, wearing your face. If all outcomes happen, then which you is real? Part 7. Wigner's friend. A twist on the cat. A twist on the observer. A twist on you. Imagine Wigner. He performs a quantum experiment. His friend, locked in a lab, observes the result. Outside, Wigner doesn't know what happened. To him, the system, including his friend, is in superposition. His friend might have seen the cat die, or live. To the friend, the observation is done. The wave has collapsed. But to Wigner, it hasn't. So who's right? If observation causes collapse, but observers disagree, then reality isn't just subjective, it's contradictory. This is Wigner's friend paradox, and it tears open the idea that there's one shared world. Because every observer has a reality only they can collapse. Only they can define. So your truths, your memories, your identities, your traumas, they are real only to you. to someone else, they may still be unfolding, or may never have occurred, and so you walk through life as a hallucination to others. If every observer creates their own reality, are you anyone's truth but your own? Part 8. The measurement that lies. You trust numbers, you trust results, but you forgot something: quantum decoherence. You think it means observation ends the superposition, but it doesn't. It just hides it. When a system interacts with its environment, air molecules, photons, your skin, the coherence of the wave function disperses. It becomes entangled with the world. The superposition is still there. You just can't see it anymore. It's not that the wave collapsed. It's that you're no longer able to notice it. You didn't cause anything to become real. You just lost access to the alternatives. That's the horror. Not that reality ends when observed, but that it keeps going just without you. You're not the final witness. You're not even part of the system. You're just a side effect. So when you say, "I saw it happen," what you really mean is, I was included in the collapse this time. But in how many other versions of the world are you excluded? And if you're never part of the outcome, are you even part of reality? Part 9. Absolute zero. There's a temperature so cold, nothing moves. Absolute zero, 273.15 grados. Bajo cero. The point where atoms stop vibrating. Motion ceases. Entropy halts. But you can never reach it. Not truly, not exactly. Why? Because uncertainty won't allow it. There will always be fluctuation, a jitter, a ripple, a whisper in the vacuum. Because stopping motion means knowing both position and momentum, which again violates Heisenberg's principle. So there is a boundary you can never cross, a stillness that always recedes, a perfection that rejects your touch. And so the universe itself trembles, always, even in the void, even in death. There is no peace, only the illusion of calm layered atop endless vibration. Even the silence screams, if perfect stillness is impossible, can you ever truly rest? Part 10. The quantum Zeno paradox. Let's return to time. The quantum Zeno effect says that a system watched constantly will never evolve. Like the watched pot that never boils, only real. Observe an unstable particle again and again, and you freeze it in place. You delay its decay. You halt time itself with attention. So think about that. Your gaze prevents change. Your awareness interrupts the world. To see too clearly is to destroy motion. To watch too often is to trap time now. Turn inward every moment you analyze yourself. Every second you dissect your thoughts, your memories, your feelings. You may be killing their ability to grow. You might be paralyzing your soul by observing it too much. So introspection is violence. Reflection is prison. Awareness is death by 1,000 looks. If constant observation halts evolution, are you the reason you can't change? Part 11. Vacuum decay. You are here, at the bottom, or at least at what feels like the bottom. But beneath this reality, there's something deeper, a trapdoor under the universe, a lie encoded into the structure of everything you've ever. Trusted physicists call it vacuum decay. The universe you inhabit, with its stars and atoms and minds, may not be the true vacuum. It may just be a metastable state, a fragile plateau perched above a more stable reality, false ground waiting to give way. And if no, when a quantum fluctuation occurs in just the wrong way, a bubble of true vacuum will form, and it will spread at the speed of light, unstoppable, silent, erasing everything, Not like a fire, not like a bang, more like a sigh that deletes the capacity for existence. No more particles, no more forces, no more you. And here's the horror. You'll never see it coming, because that bubble, that edge of annihilation, could already be on its way. It could have started a millisecond ago in a galaxy you've never heard of. It could reach you in 5 billion years, or 5 seconds. The laws of physics, as you know them, would simply vanish. Your body, your mind, your planet, your stars, not torn apart, not burned, just redefined out of possibility. There would be no remains, no memory, no one left to ask what it felt like. And yet you brush your teeth, you answer emails, you try to fall asleep. Why? If the entire universe can vanish before your next thought finishes forming, what exactly are you waiting for?